Don't do anything dangerous with that.
Okay.
You hold on to that. Who wants the hammer?
Me. Oh, darn it. I can't have it.
Okay, and then we also have some screwdrivers here. You hold on to the screwdrivers. Okay, here's the story. My door is not working correctly downstairs. We're going to go and fix it. I'm going to teach you guys screwing and nailing and hammering. No, that's not what's in the box. I'm just kidding. This is what's in the box. We're going to talk about magnetism.
I like hammering.
You like hammering? That was kind of a joke. I was gonna try to get you guys to do it. All right, let's start with what's in this bag. I'm going to show you three kinds of magnets. I'm going to show you three kinds of magnets. This is the regular kind of magnet you normally get. Let's pull out a whole bunch of them. Like, see that one right there? And they have a whole bunch of round ones. Yep. Have a whole bunch of those.
See this? The piece of this.
They're pretty strong, right?
Yes, they are very strong.
And you know what's kind of cool about all these magnets? They're all different shapes and things. Here, you want some?
Oh, dude, look. This one isn't that strong. This one isn't that
I
strong.
can't even separate these.
They're really cool because these are iron magnets. And the way these are made is when the iron is...
And there's also positive and negative.
There's a positive and negative side, yep.
Oh, I couldn't break them apart. It was hard. No.
Let me show you something, guys. In here, I've got three ways you can sense magnetic fields. You've probably heard of this, right? A compass. If we make all the magnets really far from this for a second. The Earth itself has a magnetic field, and if we get all the magnets away, it's going to tell us that north is roughly that way. Well, see, it's sensing all these magnets. We got to get all the magnets away.
I think perhaps we should move the flowers too.
Oh, the flowers? Yeah.
Sorry.
So, the Earth itself
I'm
has
just
a
going to
natural
move
magnetic
back
field.
here.
The
Sorry
Earth
for
is a
the
magnet.
wonky
But
camera
when one
work.
of these magnets comes close to that, right, it attracts the needle. So it's measuring whatever field is strong.
Kevy, would you move the
Go ahead and
flowers
move-
a little bit
go ahead and
more?
move one of
Because
those
your
magnets.
face, I want to see you. Move them
Right.
over to the thing.
See how that disturbs? These are much stronger, right? Those disturb the magnetic field as well.
Thanks, sweetie.
I'll show you another
Awesome.
one.
Thank you.
The whole thing.
Here is a cool piece of gel, and embedded in this gel are little tiny magnetic shavings. So what's really cool about this, watch this. Oh, there's two pieces of this.
I'll demonstrate.
Now don't bend it, don't put a crinkle in it. But watch, if you put a magnet behind it, you can actually see what the field looks like. Put it behind Max. See that? See that kind of, that shows you what the magnetic field looks like.
And you can make...
The magnetic field is invisible, right? And you know what? This really perplexed people for hundreds or even thousands of years because they knew certain things were magnetic, but they didn't know why,
That's all the magnets.
and it was
That's all the
invisible.
magnets.
No, that's the magnet field. Yeah.
Let me show you another way. This is the way I learned when I was a kid. We used to do this. This is sealed, but we used to have, these are just iron filings. These are just plain old filings, like off of a hammer. You just shave off little bits of iron. Watch what happens when these bits of iron are in a field and you shake them up. You see that? You see those lines? See how they're kind of standing up?
Yeah.
We're going to actually do something very similar with paper clips.
Oh yeah, I tried that before.
See that? And if you use any of those magnets, you'll get the same thing. Just put it underneath and just shake it up a little bit. You might want to put that flat. Now shake it up a little bit.
It can
And you see how the
it's stronger than it.
OMG.
So all of these dark ones are magnets made from iron that's not normally magnetic, but you can magnetize it when it's molten. Okay? So they make it such that when it's molten, when it's liquid, they put a really strong magnetic field around it, and then the iron remembers that. You want to see another kind of magnet?
Yeah.
It's even stronger.
Oh, stronger than this?
Yep.
Oh,
Stronger than this?
You've seen these before, right?
Oh yeah.
You know what they are?
Yeah.
You know what they're made out of? Yeah, this is actually an element that is naturally magnetic. Unlike iron, which is not naturally magnetic, this doesn't have to be trained to be a magnet. It's naturally a magnet. It's always a magnet. And if you look at it, Yeah, if you look at how strong they are, they're actually stronger. Look at how strong that is. See that?
And then if we put it on here, it would be
Yeah.
stronger.
I mean, if you measure the field around that, as opposed to the field around this, it's just way stronger.
Dude, look.
But you know what? You can get even stronger than that. And each one of those magnets, each one of those little balls, like this magnet, has a north pole and a south pole, right? If you actually try and stick them together, if you take two of these, you'll discover that there's some ways it likes to stick together, and then if you try and stick it together other ways, it just won't go. Because it has a north and a south. The north attracts and the south repels. Or vice versa. Yeah, you feel how sometimes it doesn't want to go together and other times it does? Sometimes it's pushing and sometimes it's pulling.
It's weird how you can feel the air between it.
Yeah, if you try and, you know what's interesting is
Try and push off.
if you try and push two magnets together and you try and go north against north, it'll push back and say, like this is north against south, see that?
I got it.
See how those are going? But if you twist it around this way, or actually if you twist it around this way, now it's going to say, I'm not doing it. See? Try and push those together.
Look, I have the force.
You feel that? Cool? And they push back. That's magnetic repulsion. If you flip one of them around, they'll go like this, and they'll attract. And if you flip it back, they'll repulse.
These are pretty hard. It's very hard.
You want to see that?
There's a ball around it. I know.
Yeah. So you know what? For a long time, people couldn't figure it out. They hadn't discovered neodymium yet. They had these iron magnets. This is relatively rare. It's hard to get neodymium. They had these iron magnets, but they thought, well, it's kind of something kind of magical. We don't get it. We don't know what the... But then you know what the real breakthrough was? They discovered that electricity and magnetism are related. Like, what I'd like you guys to do is...
I'm very scared of electricity.
So hold on to this. See how strong a magnet that is. And like, let's see. Can we pick this up? You can feel that. Try and pick the hammer up with one of those magnets. Yeah, try and use the magnets to pick it up. You think you can pick up the magnet, just the hammer? Go ahead and put it on the ground. Not quite, huh? You can't quite pick it up. It's a little too heavy, right?
Yeah. What if we put more magnets?
I'm pretty sure.
What about if we put more magnets on? Well, load them all up. Load all the magnets up. This one too. Load them all in there.
Kunitsu.
Oh, wait, that was all.
Shaka Zulu.
Now, see if, don't hurt yourself, but see if you can, yeah, see it's a little too heavy, right? Now, check out this magnet. Check out this magnet.
I know.
Let's
It's
get
just
this one
kind
there.
totally.
Oh, wait a minute. Okay, what's going on here?
Oh, it's not.
This is only a magnet. This is just a piece of metal. It's not a magnet. You see how there's two wires coiled around it?
Yeah.
Connected to a battery. The circuit is incomplete. You see how the one wire comes in here, goes round and round and round, then there's nothing connected to it here, right? And then the other one goes here. So unless we connect those two, we're not going to get anything happen. Guess what I happen to have right here? A way of connecting those two. Okay, so if we put that in there, and then we do this, you may even see a little spark. It would be kind of cool. That's not a huge spark. See it?
Oh, whoa.
See a little spark? That's the electricity going through. When I do that,
Oh!
it's that strong. And watch what happens if I let go of the current. It's no longer a magnet. You want to try it? Yeah, just hold on to it. See the battery there? Kind of hold it. I don't have it held on there. Just hold the battery to that. Oh, wait, open your hand a little bit more. Just put it around all that. There you go. Now all you need to do to make this a magnet is just touch that to that. Okay? And you can pick up anything. Pick up the or watch what it does to all this stuff. Watch what it does to that. Because it's a very strong magnet. You've seen how they sometimes pick up cars?
Yes. Well, that's
They
great.
do it with giant versions of that.
Keep it on there.
Yeah. And the moment the current disappears, the magnetic field goes away, right? It's not a permanent magnet. It's a magnet only while the current is on.
Try this.
Want to try that, Max?
Yes.
Pretty cool, huh? Yeah, Max, there's a trick. You've got to put your hand around the battery and that, because I don't really have it secured. The minute you touch it to that black thing, it becomes a magnet.
Oh, I felt that. I felt that
Okay.
magnetic thing.
Yeah, touch it and then lift it.
Touch the metal like
Yeah, touch it and now lift. See? The moment you let go of the current, it's going to fall.
So, not there. Hold on, I have to force. I have to force.
Cool. That's pretty. And I have one more thing to show you.
Yay! Where did it go? Oh my gosh! Guys, this is pushing and then lift.
Yeah,
That's the fun part. You can't really this. It's
sure.
look
All right. The one more thing I want to show you is when they figured this out, there was a guy named Michael Faraday. You remember Michael Faraday from Congress? Who figured out, hey, now that we know what it does and how it works, I bet you we can put it to good use. And you know what he built?
Look, guys, it's magic. I actually control it a
Okay,
bit.
Max, give it a spin. See if it keeps going.
Will it ever stop? No.
Yeah, it's going. You know what this is
Hold
called?
on. I'm gonna use the force. Just stop it when I use the force.
You know what this is called?
I'm trying
This
to stop it.
is
Dun, dun, dun,
an
dun.
electric motor. This is an electric motor. This is what Faraday built way back when. Yeah. See, if we do this, it'll stop,
You
right?
can actually control magnets with a
Yeah, now
a
give it a bit of
negative
a kick.
force. Hold on.
All you
You
gotta
can
do is
control
touch the
magnet
nuts
with
of
a
the
negative
metal.
force.
Now give it a little kick. Here, like this.
I hate you.
Probably
turn it this way.
I love you.
Yeah,
Alright.
just spin it a little bit.
Hate
Oh,
you.
not too hard because it's very fragile. Yep, put the leads on it, Max.
Oh my gosh.
Let's see, put it on like that and then just spin it a little bit. There it goes. So what's happening is, the reason that works, you can even feel it, right? You can kind of feel the magnetic field pushing.
Whoa, dude.
This wire is actually specially built. If you look at it very carefully, see how it's shaved? The insulation is shaved on that side, but it's not on that side, right? So when this is like this, there's current going through from there to there, and the field wants to spin it. When it
That's
goes
all right.
here,
Thanks,
the field
sweetie.
turns off.
Thank you.
So every time it spins around, the field is turning on and off.
One is like this.
Guys, look. I made the ultimate.
And you know what we could try? That's 4 volts. How about if we did more voltage? There's more voltage on the 9 volts. This is 9 volts. You want to see if it goes faster if we give it more voltage?
Yes.
Okay, so let's get rid of those
I want it to
puny
be-
4 volts. And then let's put this on there. Okay, load it up, Max. And get ready to spin it. Just put it right in the... Yep, now get ready to spin it. It might just take off on its own. You know, it's not quite straight. Let's get it straight.
This is the ultimate.
So it's cool,
magnet.
because all that is a piece of wire that's been shaved off in a particular way.
Yeah. I want some.
There it goes.
I did it. I did it.
Oh.
Whoops, except it's trying to escape. See?
I
More
see
voltage.
sparks. I see
More
sparks.
voltage.
I see sparks.
You know what those sparks are?
What?
That's the
Are those electrons?
that's the current making and breaking. See?
No, are those
Remember how it's
electrons?
insulated on one side?
Are the electrons?
Electricity.
I want to
Yeah.
see electricity. I want to.
If you look right
want to
there,
see shocking.
if you look right there, you can kind of see
Oh, I
sparks
actually
going
see it. Oh, yeah.
there. And that's the current making and breaking.
Electron.
Cool, huh? And we could let this go for as long as the battery could feed that.
I want
Let's see if
to
the
build
battery's
an
getting hot.
atom.
No, it's getting a little warm. See how the battery's getting a little warm? That's because we were drawing current out of it. Pretty cool, huh? Play, explore.
That was awesome. Oh, and I just learned something. Ah!